Hey class, Mr. Husted here, and this is Chapter 1, Lesson 1, Identify Points, Lines, and Planes. As we go through your notes here, you'll see that any useful vocabulary will be found on this side of your notes page, and all examples will be found here in the middle, and I'll be filling stuff in as we go. So to take a look here today at some of the vocabulary, I'm sure you've had some of it before. We've got point, we have line, we have plane. We're going to talk about collinear points, coplanar points, line segments, rays, and any type of intersection that we have there. All right, so let's go ahead and take a look at example number 1. Example number 1 asks us to give two other names for line PQ and for plane R. So let's take a look at line PQ first. So line PQ is right here. It's this line that's going through there. Maybe I should have picked something other than red to use, so it's a little easier to see. Right there, PQ. So how we name a line is any 2 points on that line or by a lowercase letter associated with that line. So if I want to give 2 new names to line PQ, the easiest one to go with is line QP. And because mathematicians can be lazy, we don't want to write out line. If you write it out using a line over top with arrows at each end, that means line QP. Okay, so we've done line PQ, QP. The only other way to name this is by using the little letter that is associated with it, and that is the letter N. So we will say line N. So those are 2 ways to rename line PQ. Now let's talk about plane R. So plane R is this plane right here, encompassed, kind of looks like a little sheet of paper right there. That is plane R. So how we name plane R, there are a couple of different ways. Obviously by using a big uppercase letter in one of the corners, or by using 3 points, but they can't be on the same line. So non-collinear. Okay, so 3 points not on the same line. Because if I use 3 points that are on the same line, I'm naming a line and not a plane. So to name this plane, I'm going to have to use point V, and then 2 of the points from this line right here. That line is inside that plane. So there's a couple different ones you could choose. I'm going to start out with plane V, and then I'm going to pick SP. And then I'm going to do the same thing, V, and then PT. You could also do, you could switch the letters up a little bit, but you just have to pick 3 points not on the same line. Okay, so that's how you name a line and a plane. Next question asks, name 3 points that are collinear and 4 points that are coplanar. So, collinear, it's all in the name. Co meaning the same, linear meaning the same line. So if I look up here, I'm looking for objects that are on 3 points that are on the same line. So my only 2 options for this are this line right here or this line right here. This line right here only has 2 points. They have Q and P, whereas if I use this one, I have S, P, and T. So 3 points that are collinear would be point S, point P, and point T. You can use the little dot out to the side referring to a point, or you can write out the word point. Again, you'll find for me that mathematicians are a little bit lazy at times, so I like to just use the little symbols for it. So those are 3 collinear points. Now we want to look at we want 4 points that are coplanar. Same kind of idea. Co means same. Planar here it means the same plane. So we're talking about this sheet of paper looking thing, looking for 4 points that are on that piece of paper. Well, as I look at this, I only see 1 point that is not on that piece of paper, and that is point Q, leaving me with V, S, P, and T to be on that same plane. So point V, point S, point P, and point T. Those points are what we call coplanar. All right, let's take a look at example number 2. Example number 2 says now that we are going to name segments and rays. The first thing we're going to do is we're going to give another name for line segment GH. So GH just means the area between these 2 points. I could have also written GH here in the notes as GH with just the line over it, no arrows over top of it. The arrows mean it goes off for infinity in both directions. Without the arrows, it just means that point, those points in between there, or the space in between there. So the only real way to rewrite a segment covering this amount of area from G to H is to just simply flip it around. So instead of going G to H, we're going to go H to G, and we'll put the little line segment symbol over top of it. Okay, that's how you name a line segment. Now a ray is very similar to a line segment, except it starts at a point and then goes off to infinity in the other direction. So for example, we want all the rays with endpoint J. Endpoint means it's going to start at J. So we want to start at J and we want to extend through a point all the way off to infinity. So one of those would be to start at J and extend out through F. J is my endpoint, so I start it there and I put an arrow over F because it means to extend into F's direction through infinity or out to infinity. So we want to name all the rays that have endpoint J. So I have JF, I'm going to have JG, I'm going to have JH, and then finally I'll have JE. Notice how all of them start with J because J is our end point. Then they extend on to these other points out in those directions into infinity. All right? Okay, let's flip over to the back side. So now we're gonna work on our drawing skills real quick. So sketch a plane and a line that is in the plane. So a plane just looks like a sheet of paper. Okay, we'll call this plane P. Remember, to name a plane, you can use just an uppercase letter. And then a line that is inside the plane. So to make it look like it's inside the plane, just make sure it falls inside the plane. And to name a line, you can either use 2 points on the line, we'll call it A, B, or you can name it by a lowercase letter associated with that line. So line L. So that is a plane with a line inside of it. Example 2 asks us for a plane and a line that does not intersect the plane. So I have my plane again. We'll call it plane P. But I need a line that does not intersect the plane. That's pretty simple. Just maybe draw it out here to the side. And we'll just say that those two, they never intersect. There's no way that this line will intersect that plane. Okay, so a plane that does not intersect, or a line that does not intersect the plane. And then finally, sketch a plane and a line that intersects the plane at one point. So again, I'm going to draw my plane, plane P. Then I'm going to draw my line. I got to make it look like it's going through that plane. So I'm going to make it intersect at that point right there. We'll call this point A. and point B is out here. Now, to make it look like it goes through the plane, we're going to dot that line while it's underneath and then extend it here. And then I'll also give it its other name of L. So in this picture, it looks like we have this plane and a line that goes through it intersecting at that point. Okay? All right, and the last thing is to sketch two planes that intersect in a line. So when two lines intersect, they intersect at a point. When a plane and a line intersect, they also intersect at a point. Now, when a plane and a plane intersects, think about two pieces of paper that are kind of overlapping each other. And I am not a very good drawer, but we'll see what we can do here. So, try to see here. Nope, we'll make that full. And then bring this down. And they kind of intersect here. And then this will be dotted out to here. To here. And so you get kind of the idea. What I want you to see is that when these two planes intersect, they intersect at a line. Okay? So just to kind of review that, a line and a line intersect at a point. A plane and a line intersect at a point. A plane and a plane will intersect at a line. So hopefully you've gotten the gist of points, lines, and planes. If you have any questions, bring them with you to class, and we will see you then.